having a wee look at this here question. Um, First of all, what I'm going to do is I'm going to split them all up into the separate integrals. So I'm going to write that as cosec squared 2x dx plus the integral of x to the half dx minus bringing that 3 outside, 1 over x, plus e to the minus 3x dx. Cosec squared, if you think back, cot goes to minus cosec squared. So I need a minus in front, balance it outside. Derivative is a 2, balance it with a half. So when it integrates back, it's going to go back to the cot. So cot 2x. To integrate this, you add 1 and divide by it. Divide by a fraction, it's just the same as turning it upside down. Derivative of the bottom is on the top, so just log the bottom. For this one here, if we integrate an e, you must have the derivative in front, so balance it outside, 1 over minus a third. So it's minus 1 over 3 e to the minus 3x, and don't forget your c. The area and this one, so it's this curve, take away this one. So I like to separate them out to help me integrate them. So cos x dx minus, the integral of that is just a wee constant, that one's okay, and plus this one here shouldn't be too bad. Now where does cos come from? Cos comes from sine. So sine goes to cos, so it just goes back to sine, nothing fancy needed there. This is a constant, so you put your x back in again, and that becomes x3 over 3. You've got values to plug in, so pi over 2 and naught. So putting in pi over 2, 3 sine pi over 2, so pi over 2, sine pi over 2 is 1. Over here, you've got pi over 2 times pi squared, so it's pi cubed over 4, and then that's going to be the 2 there, so it's over 8, plus pi cubed over 8 times 3 is over 24. Putting in your 0, so 0 minus 0 plus 0, everything disappears. And just to tidy this up a wee bit here, putting in both over 24, that is minus 3 over 24, plus 1 over 24 is minus 2 over 24, which is minus 1 over 12. Now, from the same year, we're going to go to the C4 paper, and we're going to have a look at question 1. Question 1 is wanting it written in partial fractions first of all. So a over the first factor plus b over the second factor. Make the top lines, fix them. This one needs an extra 1 plus x. This one needs an extra 5 minus x. Choose x to be minus 1. So it's minus 9. That one disappears. 5 minus minus 1 is 6b. So b is minus 3 over 2. Choose x to be 5 to get rid of that bracket. So 2 times 5 is 10, take away 3. 5 add 1 is 6a. So a is 3 over 6, or a is a half. So your expression is rewritten as a, which is 1 over 2, 5 minus x, plus b, which is minus 3 over 2, 1 add x. Part 2, you're going to integrate this. So what I'm going to do is I'm going to bring that half outside and leaving me like so. I'm going to bring this 3 over 2 outside, leaving me with this. To integrate a fraction, you must have the derivative on top. Derivative, that's a minus, so I pop it there and balance it outside. Now I can log the bottom line. The derivative of this one is a 1, so it's already there. So it's 3 over 2 log 1 add x plus c. And that is that one finished. I'm going to have a look now at question 3, a substitution one. You are told what substitution to use. So do your du by dx. If you differentiate that, you get 3. Rearrange that. You get dx is du over 3. So we're going to put that in here. So dx is du over 3. Square root, that is your u. Now, x, if I take this and rearrange it, so u equals 3x minus 5. So u plus 5 is 3x. I want 6x, so just double everything there. So I can write 6x as 2u add 10. Now, integral signs. You have got x equals 2 for the lower integral. So u is 3x minus 5. So 3 times 2 is 6 minus 5 is 1. So u equals 1. That was x. And then do the same for x equals 3. So where's my, there we go. So u is 3 times 3 is 9. Take away 5 is 4. So it's u equals 4. Now what I'm going to do is I'm going to tidy this up a wee bit. So I have got 2u over 3 root u, add 10 root u over 3, and I'm trying to integrate everything. So this is 2/3, u to the 1 over u to the half, subtract the powers, you're left with a half. Write that one as the power of a half over 3. I didn't split the integrals because we should be able to do this okay. So for this one, you add 1 to the power, so it's 3 over 2, and divide by it. Dividing by a fraction is the same as turning it upside down. You already have 2/3 times another 2/3. Adding 1 to this fraction, you have 3 over 2. To divide by it, you turn it upside down, so that's the same as 2 times 3. And your units, sorry, your limits are 4 and a 1. So let's tidy this up before we go any further. I have got 4. So I'll double check here something. Yes, just notice there's a mistake there. Just thought it was coming down here, it didn't look right. U to the 1 times root u is u to the 3 over 2. Add 1 and divide by it. And this one here, yeah. So that's us looking a bit better now. So I've got 4 over 15 u to the 5 over 2 plus, this is going to be 20 over 9 u to the 3 over 2. Now I'm going to substitute in my values. Substituting in 4. Square root of 4 is 2. 2 to the power of 5 is 32. Plus 20 over 9. Substituting in 4. Square root of 4 is 2. 2 cubed is 8. And then substituting in 1. So it's 4 over 15, add 20 over 9. So if you just work this out in your calculators, so the first bracket hopefully is 1184 over 45, and the second bracket is 112 over 45, and just working this out to give you a final answer, I have got 107.2 over 45. I would give that as to 3 significant figures, a bit more sensible answer. Okay, number 4, volume. So remember the formula for volume. We're going between 0 and 1, and it's y squared. So it's ex add 1 squared dx. So we'll just go through the quick way of squaring out the brackets. Square the first. So power to power means multiply. Square the last, 1 squared, and double the product. So it's a sine, 1 times 2 ex. Now I'm going to split that up into my separate integrals. So the first one is e to the 2x dx plus 1 dx plus 2 ex dx. Now, to integrate an e, you must have the derivative in front. Derivative is a 2, balance it outside. So that will go back just to the e function. X just reappears. Derivative is the 1, it's in front, so I can just integrate it back. Your wee limits are 1 and 0. So putting in 1, so it's half e2 plus 1 plus 2 e to the 1. And then subbing in 0. Now remember, e to the 0, anything to the power 0 is 1. So half times 1 is a half. Plus 0 plus 2. And working this out, you have got pi, and I've got a half e squared plus 2e, and 1 minus a half is a half, and a half minus 2 is minus 3 over 2. And just working that out on your calculator, we don't often use the E button, but it's that one there. So it's Shift E, and we're going to square it, move it across, divide it by 2, press equals, plus 2 times E to the power of 1, move it across, take away 1.5 and times the whole thing by pi gives me 23.97 to three significant figures, 24.0. Now it's asking you what assumption, and you have to say, if you imagine you're spinning it around those axes there, so it's going to have a flat base. If you can picture that going round the axes. Okay, we've still got another one now, number 6 from this paper. It's the last one we have to do. Okay, so going back to this trig, one of the older topics. So the expansion of sine is sine x cos alpha minus cos x sine alpha. So 7 sine x minus 24 cos x equals r sine x cos alpha minus r cos x sine alpha. So let's look at our sine x's. On this side it's a 7. On this side it is r cos alpha. Do the same for our cos's now. So our cos x's. On this side it's a minus 24. On this side it's minus r sine alpha. You can go to two minuses. Equation 1 and equation 2. Just as normal, just do equation 1 plus equation 2 and square them. So 7 squared at 24 squared equals r squared. And if you work that out, then square root it, you get r to be 25. And then you want to get the tan out of this. So remember, tan is sine over cos. So it's equation 2 over 1. So if you put the r's cancel off and sine over cos gives you tan 24 over 7. That's always the acute angle they want. So all you have to do is inverse tan 24 over 7. And just straightforward onto your calculator there. And you should get 1.29 to three significant figures. Okay. Now, if you look at this, this is the expression that you've just worked out up above. Now I'm just going to write the question out from up above so you can see what I mean. R is 25 sine x minus your alpha. So instead of having this expression down here, I'm going to write it in this form. So it's 1 over 25 sine x minus 1.29. Just be careful, the whole expression has to be squared. So what does that mean? 1 over 25 squared is 1 over 625. And now I've got sine squared this angle. 1 over sine squared, I'm going to bring that 625 out. 1 over sine squared is the same as cosec squared. So it's cosec squared this angle. Okay, cosec squared is one of your trig identities on the list because cot goes to minus cosec squared. So I need a minus. The derivative of this is a 1 and I've got a 1. So I can integrate that back to give me cot x minus 1.29. And don't forget your c.